Okay, everyone, welcome to DIGA630. We're in our week 2 materials this week. As we noted back in week 1, I shared the idea about offering this up as a kind of as a optional drop-in period where we can just drop in and follow along and come and go as you wish for anybody that is here or others that may join, completely optional. But the idea for week 2 is that I'll be stepping you through some of the materials from kind of part 2 of last week that involved our spatial manual that we were using in week 1. So you may want to go back and pull that up as well as we're going through our materials. For folks joining us live, we'll be going through that spatial manual. So if you do have that up, that'll be great. And so the way this period will be chunked up will be more discussionary and stepping through some of our objectives for the week in slightly condensed format compared to a 5-hour session, because our online session this week is also intended to be part of a lot of exercises and things like that that are included in that 5-hour block. So with that being said, our entire part 1 of our discussion here really will not be going super long, at which point then we'll truncate that and then move into a couple of other in-class activities that will be posted this week, such as our Brian problem, our spatial application exercises, and a couple of other in-class activities that we'll break out for you in some separate videos. So look for those to appear here as well for week 2. With that being said, let's go ahead and take a look at our agenda for week 2. For our agenda, predominantly as I outlined here for us, why is this we'll notice right off the bat here that this agenda for some reason is not linking to the right dates here, but so I'll have to double check where that link was to. So obviously the date is wrong for us starting off the bat here, but I think the content nevertheless should be similar. We'll be working through some of the problem sets and the Brian problem, as well as part 2 of our spatial analysis workshop that you'll notice right here. And to that end, before we forget, activity 2 for week 2 are to complete, there is a reading as well as a tutorial in 2 different files. So you can choose what works for you. Just prior to the recording, we're visiting that there's a lot of challenges between linking up book content with software content and then another type of software like ArcGIS Desktop, ArcGIS Pro, and then we have supporting resources for those. So what am I trying to say in all that? We're trying to give you a package that will be suited best for you. I would encourage people to consider ArcGIS Pro and the resources supporting that. Given that though, with whatever version of software you have, with whatever version of our book content that support our tutorial, that'll be found in one of these folders that I'll direct you to here, the Pro folder. You'll notice that there may be some slight nuances between the tutorial and the software or vice versa. They're not going to be enough to really hold you up, I don't think, but if you experience one, depending on what version you have, please let me know and I'll try to help you out with that. But otherwise, the tutorial is purely to kind of get you acclimated and how to work through some different data sets from beyond what we were both last week and then what we'll be covering this week. So nevertheless, pertaining to week 2 and our activity number 2 or assignment number 2, last week I shared out with you all a shared Google Drive folder called DIGA630, and that folder will look similar to this. So DIGA630, and here we have our week 2 materials. Down at the very bottom of our week 2 materials, you'll notice that there are a couple of folders in there, or the main one I'm encouraging folks to work with would be the ArcGIS Pro zip folder. And that folder, inside of that, if you right click and download that, you'll have to right click and extract that content as well. But if we have that, or if you're able to download that, so for instance, the ArcGIS Pro E1 folder, if I just show you what's in there, there are a number of different files in there, and some of them data, some of them some sample student data that you won't see in yours. But a couple of the files that you will want to go through, the number one is called Mastering the Concepts. And if I just open that up to show everybody briefly what that consists of, will be that of a major reading. So you'll want to read through this one, power read it, and get a sense of what's happening. But these are the concepts that are going to support largely what we've been discussing in week 1 and in week 2. So it's going to give you a little bit more depth beyond what I can do in the time that we have here this week. So it's kind of the background filler reading. And ultimately, the reading for this that we're looking at right here on the screen will help prepare you for that of the tutorial and the assignment that we'll talk about here shortly. Okay, the second PDF out here is called Mastering the Skills. This PDF is really the tutorial that I'd like to encourage you all to work through. Again, I don't think really anything that you need to submit for this, but it will help you with the assignments, the 2 assignment problems that are listed at the back of this tutorial. So as we scroll through this, you'll find the different data types that are needed for the tutorial, and those tutorial data sets again are going to be provided in some of these folders out here when you unzip that ArcGIS Pro E folder, if all that makes sense. Okay. All right. Now there's so many folders opening, I can't quite remember where we're at. All right. So I advise everybody to go through that tutorial. Move this window out of the way. And then once you get to the bottom, all the way to the bottom. So I'd dedicate some time to this. And again, you don't have to worry about necessarily submitting these answers or anything in the tutorial. That's not what it's about. It's just to get you familiar with functions and processing. But at the end, you'll see these practice exercises. And the data that you'll need for these exercises should be in this Black Hills Sturgis database. And if anybody has any problems with this, please let me know. Make sure that you're in the right database, as in, for instance, times where we have used this, people ended up in the wrong database and then couldn't find the right data sets. And to that end, there may have corrected it, but something tells me that there was maybe a missing file in here somewhere, and I can't remember quite what that is offhand. I think it's taken care of, but if not, or if you can't find anything, let me know, and I'll make sure that we get that squared away. It just something seems like it struck a bell for me in there, but maybe I'm imagining it too. So the idea for the assignment for this week then would be to, after completing the tutorial, use the same data provided for that tutorial and select 2 exercises at the back of that tutorial packet to work through. The choice of those 2 exercises are completely up to you. If you'd like to work with someone, that's totally fine on that as well. And so in the end, we're not looking for a super long write-up or anything, but maybe a 1-page type of a concept that introduces the problem, kind of a bulleted listing of your methodology, what you did to solve the problem, and then a final screenshot of what your findings look like. So it's kind of an intro, bulleted methodology, and then a half-page screenshot or something like that of what you found. So, and then drop those into a Word document. So you might have 1 Word document with 2 pages or something like that for problem or exercise 1 and exercise 2 or whatever it might be. So you want to upload those to Canvas then, and but let's come back over here to that tutorial. So you'll get a chance to select any one of these. I think there might be like 10 in here. 10 of these that you can choose from, and some of them are going to be a little bit more involved, a little bit less. So use this as a scalable opportunity to help you out, in this. So pick a couple that work best for you. While there is an answer key provided in here for the tutorial and the exercises, this can certainly help. I think, trying to remember here if this is the answer key. I think there also is maybe another supporting answer key with the desktop version as well that you'll want to, or that might be out here as well for you. So in the desktop version, I think there's also a solution guide for that too in there. But nevertheless, these things are there to help you out if it can. So for folks who are joining us live, are there any any questions or anything like that on the overall assignments or anything like that? Again, the agenda is linked to somehow the wrong agenda here. Apologies for that. Otherwise, in short, go through mastering the concepts, read that, go through the tutorial, and then answer 2 questions or 2 exercises at the end. Okay. So that's really what we have for week 2. And our discussion and some of our in-class activities that'll be broken out into a couple different videos here for this week will be reinforcing a lot of our per cell analysis. Some of the global and neighborhood analyses that you're seeing here for objectives will be covered in the mastering the skills, mastering the concepts guides that we just looked at. So those are kind of that background information where that covers a lot of that material for us. But in general, we're going to learn how to scaffold and build upon data analysis principles. So understanding data, building workflow, building diagrams to help us understand data and analyses a little bit more. Okay. So obviously our video here will be replaced with our fall 21 content right now. And there also is a general raster analysis presentation. I kind of think of that as mostly a guide. You can breeze, kind of breeze through that, look at the pictures. A lot of that content there will be supported with your mastering the concepts, mastering the skills tutorial for this week. And then also have a couple board notes and graphics that you can refer to. Also for this week, we'll have workshop, kind of part 2, the Brian problem, which will be a video provided for that. There'll also be a separate video provided for spatial application exercises, as well as some in-class activities. But I do have a word solution guide up here and some sample syntax that I encourage you to look at. We'll pull that up and look at that briefly throughout our different exercises here this week. And then I'll be uploading here some of our demos for our spatial application activities here shortly. So they're in ArcMap here right now, but we'll be redoing those in Pro as well. So data for these workshops and the Brian problem scenarios are all provided in here. The scenario PDF, as well as data that you might need, and spatial exercises, a Word document. I don't know why there's 2 in here, but we'll have to check that out. And then a solution guide as well to help overall with everything we're working on, as well as data. So that is that. Okay. Folks joining us live, any questions where we are here tonight? Otherwise, we talked about our spatial modeling activity, which was the tutorial. Select 2 of those questions. And then also, don't forget, there's a short little easy quiz to go through. All right. Thank you, Devin, on that. All right. So to begin, what I'd like to do is come back to where we left off from last week. And whether or not we covered this in 1 week or not, these concepts are always going to overlap. And that's the good news, the fun news. And so I did want to come back and spend a little time doing some review, some basic review with you. And folks joining us live here tonight on our optional online session, anything that you can think of from last week that struck you as interesting or fascinating, or something that you remembered that we could kind of get our minds going again. And folks at home, or whether you're watching this later, what are some things? I always find these as really good reflective moments to really tie together our week. So I encourage you to pause a recording here and think about a few things from last week that you can carry over. It kind of brings your mind into where we are here now. But folks joining us live, anything that you would like to recall from last week, just in a brief review for a few minutes here this evening.
That no data is stored as a large negative number instead of a 0. I did not know that.
Yeah, that's kind of that negative 9999 that we'll see as a no data. If you're to click on something, sometimes we'll see ND, there's no data, or it might say negative 99999, there. So that's what no data is stored at. No data is no data, 0.
That kind of stuck out in my mind though, as something being peculiar or unique.
Yeah, it's a new concept as well, especially when we haven't really had a chance to work with it all that much. But good. Other thoughts or comments from last week?
Well, you and I talked, John, kind of back and forth, and I didn't get a chance to rerun it with your data because I have to use a different computer because it says I have a newer version because of what I've created. And since all of our stuff is the same from what I sent you, and I'm not advanced enough to know how to have two of the same files. So I have to use my son's laptop. And when I haven't had a chance to rerun it, but for whatever reason, when I ran that tool, I did try it multiple times before I ever even emailed you. So I created different masks. I opened entirely new projects, created a whole new project, started from scratch, and I still was getting the same thing. So it really was annoying to me that you opened my thing and did it right away.
Yeah, and so, I think if we were going back in there, and I'm just leaping through my notes, so for folks at home or joining us at a later date, what Nicole was referring to there was working with the assignment, and part of the assignment, and I know there's a video up there, so you kind of check all that stuff out. We're dealing with resampling. And with that resample tool, since I do not have that up here, but let me just pull that up. Nicole's having problems followed exactly everything I was doing. And for whatever reason, the resample process from a 5-meter cell size to a 25 was still pulling the attributes from Nicole, your 5-meter raster, essentially.
But it worked for my 50, and it makes no logical sense.
Yeah, so, and I'm not sure what happened in that. That's one of the weird things with Pro that, or well, we can say weird things with anything. Why does something happen the way it does? I'm not sure. And really, to that end, the idea was, if I just pull up as a good reminder, where Nicole is using the resample in that activity for our working with masks and things like that, where we have an opportunity, in this resample to say, okay, I want to bring in my input raster, which for us was our smallest cell size raster. And we'd obviously give it a new name. And then our input, for our activity last week, for week 1, was 25. So Nicole was running this, and for whatever reason, the attributes were just pulling over. So from the 5-meter cell. But what we also looked at, and why I was really interested in this too, Nicole, and I know you checked this, but since it was review time here under the spatial analysis tools, we looked at, we're doing the raster calculator. It's a good review for everybody to double check. Nicole was good on this. I just don't know why the issue was happening, but we always want to double check to make sure that our inputs are correct, or that our mask is correctly, set, that we didn't have a mask enforced. Because remember what happens for folks in person, if we leave something here and we forget about it, what happens? If folks at home, think about this too.
Stays there.
Stays there. It'll stay there until we blow it out of there. So, short answer is, Nicole, I don't know what was happening. And Pro does have some.
I know. I don't know. You don't know. I'm like, I gotta be doing something, but I'm literally like, our inputs are the defaults, so I shouldn't be having anything weird. And I created new polygons. I literally deleted I even made my own database, created a new one, deleted the whole new one, made a new one, just to try to see if I could run it different ways. I mean, it doesn't make sense. It's working for 50. That doesn't mean that the numbers were correct, though. That's, I think, what was important for me to understand, even though it was running for the 50. meter one, and I was getting different attributes, smaller numbers, which is what I would expect, doesn't mean it was correct numbers if something was wonky.
Yeah, I'm not entirely sure on that. And since we were talking about rules, don't forget to do certain things here and there. These rules are a great place to come back to remember certain things. And Nicole, just on yours, without going too much into the weeds here on that for everybody else working on their stuff, but did your file, I didn't check your path names obviously there, but were those all good? No spaces or anything like that in there?
No,
It was not good?
no, they didn't have any spaces or
they didn't.
anything
Okay.
like that. No.
Correct. Okay. So, I'm not sure, we'll have to visit on that, Nicole, but I mean, in the end, you have some things that can work, but I don't know why that is. There's certain things in Pro I can't explain. I literally, particularly with imagery too. I don't know. I mean,
I'd just be interested if anybody else had a similar issue, if they could let me know.
yeah, so if anybody in our current session or online too, joining us later, has had an issue with that, drop me a note or could maybe put another problem solving discussion forum out there too for this week where people could drop some tips and hints or problems. That might be a good idea for me to do, kind of a community problem solving board for this week and next week. So thank you, Nicole, for sharing.
Did you ever try restarting your computer? Like I didn't have that issue with Pro, but I used to have weird issues like that with desktop when I was running a lot of raster processing, and it would like remember weird things and I would just have to like redo everything.
Yeah, I restarted. I created new projects. I did all kinds of stuff. I even used my son's computer. So I have no idea what was going on. I checked the history. Anyways, it's an anomaly. I'm sure user error somehow, but I don't know.
Well, yeah.
Or there's a glitch somewhere in my stuff.
Well, the long story short, I think it is a glitch because I was able to use your data without any problems. So, maybe Nicole, after this or this week, we can hop on a quick Zoom together and you could show me what's going on, and we'll try it again. But,
Okay, thank you.
yep. Okay. Let's see. Devin had a chance, and Nicole had a chance. Heather, if you're joining us live here again, anything that comes to your mind from last week besides fun, excitement, and a ton of enthusiasm?
I just say the reminder, to get in the habit of exploring your data. Like I normally work with vector data, so I don't work with rasters as much. And so it's good for me to, even if it's overkill, to just like always be checking the properties and exploring the data just to make sure that what I'm doing is coming out like it's supposed to. It's just a good habit to get into because I think you get, a little complacent the more and more you work with it and you don't check it as much. So.
Agreed. The exploring your data is by far the most important rule that I can suggest for people because it dictates everything that we do, and so we did cover a lot. We went through area. We also talked about discrete integer grids, so people can go back through, leaf through that. Part of the idea coming into this week is that folks would have kind of browsed through chapters, 1 through 4, 9 and 10, not memorizing anything, but just kind of getting familiar with some general terms, I guess, more than anything. But with that being said, let's go ahead and continue. Or was there anything else that anyone maybe had that you wanted to share? Otherwise, we'll go forward here and talk about a bit more on no data and what that ultimately means for us as analysts and all of that. So when we're looking at no data, as Devin joining us live here tonight was saying, no data means no data. It's just kind of nothing, or it's obscured cell. It's not even a value. It's just nothing. But 0 definitely is a value, where no data isn't that way. But in our processing, what we're seeing whenever we're running through no data is that anytime there is any type of a function going on, with no data, the output is always going to be no data, or at least that is the typical default way that functions. But no data plus 1 is no data. Again, this is a great example of a per cell. Cell here, cell here. 1 plus 1 is 2. No data plus 1 is no data. And then over here, 1 plus 1 is 2 here. But there are ways that I mentioned before that we could change no data into a value. We can use a process that you'll be learning about this week in your readings and tutorial called reclass or reclassification, where all a reclass is an ability to, and we'll do that in some of our exercises this week too, but reclassing values just means we're changing them. So if we no longer want a section of our raster and no data, we can reclassify that to a different value, or to 0 or 1, 2, or 3, or whatever we want, or we can leave it as no data. So a lot of times people enjoy using reclassification because it enables us to change values, turn them into something else. We also last week went through a process of testing and setting null. We ran those tests for is null versus set null. And so we can set null. So here's an example of doing things the same way. We could use a reclassification that you see here to change any of our values in any raster to no data. We can also use that set null command, or that set null function that we went through in Raster Calculator. So a lot of different ways we can do something. The idea in these first couple of weeks is just to show you the ideas and possibilities that are out there. So let's go ahead and we'll take a look at, we did some work with that last week with no data. So we should be feeling pretty good, in pretty good shape on some of that. Well, let's go ahead and we talked, I think, about storage of grids. This is our rasters. Again, when I say grid, I really mean the raster, but these are how a lot of our rasters are stored. And we spoke of when we're working with rasters, it's always good to use catalog or another means of copying this. I mean, you can go into Windows 2 to do this, but make sure that you're grabbing that info folder that is at the same parent level. Like for instance, let's say this is our vegetation raster. The vegetation raster contains a lot of our statistics, and we looked a little bit at that, our attribute table, or VAT, value attribute table. But if we're moving that in Windows, we can't just right click on that Windows version of a raster and move it. We also need to make sure we capture that info file with it. So what do I mean by that? Well, if I come back over here and let's come down into, so here's a slope. This is a raster. I can't just copy this. In order to do this effectively, I would need to, really copy both of those. The better way to do it, copy it in catalog or in your GIS, whatever it is that you're using for that. So that's what that's about. Let's go to 322. So you want to flip to 322. I think we spoke briefly about this adaptive run length compression that's going on. And this is really that transparent processing that goes on behind the scenes that you don't really see, but when the software is running from 0 to 100%, what it's doing is essentially encoding and compressing all the files in your raster and the values. So in this case, we're starting off in column 1, and if we look down at the bottom, these rows, which you can see way at the bottom here, it says 1 to 16, there's nothing. So we take a look at the first row, goes all the way across, and that's encoded. Here it's at row 1 through 16, being that there's 16 columns. Row 1, 16 columns, nothing there. And then come down here into row 2, it says columns 1 through 9. There's nothing, or it says 0 right here. But in 10 and 11, and columns 10 and 11, there are cells here that have a value in it. Whatever those are, we don't know really, but said, okay, there's value in there. So I'm encoding that and compressing that. And then 12 to 16 nothing. So this is just more of an idea to let you know what's happening in these per cell types of functions. And when this is all being encoded, the software is essentially doing the same thing, but in different ways. And I have a little sketch up on my note version right here, such that focal, or what we'll call a local is really called a per cell, and you'll see different notations of that in the spatial manual that we're going over. You see different examples. Just about everything we do is going to be a local or per cell, with an exception of if we're doing like zonal statistics, which we'll be getting into this week with some of the readings and tutorials. The neighborhood types of analysis are usually, I see that in imagery a lot for like smoothing functions, or if you're trying to average out floating point data sets that are going to kind of give it a smoother look to that, like within the bathymetry, with the Caltopo grid that we were working with, you could run a smooth function on that with a neighborhood window like this, and that kind of just sweeps across and smooths that out. The other is a global layer that you may use a lot, which is really sort of everything. When I say everything, we're evaluating, like here's a good one for like a watershed analysis. Like if we're talking about that, if you drop a water, where would that flow to? And it's sort of evaluating all the cells together on a global type of a layer, a global type of a function. So anyway, how we're compressing that, how we're working with all those different data sets, the data is being compressed. It's just a matter of what type of function that we're working through. So let's go to 436. So 436, and I think I'm trying to remember here if we did a little bit with some of our masks and set cell. I think we did some of that. Correct me if I'm wrong, folks that are joining live here. Did we get into any of the concepts there of our set cell and what's going on behind the scenes with that? Anybody remember?
I don't think we got that.
Didn't think okay. Well, we'll try a few things. We'll see what we can do. Maybe run through some demos of that with some notes that I have here. I'll pull those up here in a minute. But set cell is another way of just changing your cell size. Another way we could do this is with our changing the cell size like we did last week. We entered in our cell size in a resample, so we could resample our cells upward. Now, setting the cell size doesn't have to be necessarily a command like it is here anymore. Instead, we can just kind of drop in the raster calculator. We just drop in what we want our cell size to be. If we want it 30, we can enforce that. But conceptually, that's what I'm interested more here of saying. They enforced a cell size of 30 in this example. Then they created a new raster, and they said, they're saying, software, I want you to take this in grid, whatever the grid name is, it doesn't matter. These are just names of arbitrary grids for example purposes. They said, software, I want you to take this grid or in grid, multiply whatever those cell values are times 4 right here. And I want you to write it to a new grid called out grid. But while you're doing that, I want you to change the cell size from whatever this was, whatever our in grid was, into now a new cell size of 30. So what's happening, we're obviously multiplying. Well, I don't know if you can, I'm going to draw this in here a little bit cleaner. Kind of maybe see those bigger lines in there, perhaps. I don't know how well then you can really see that, but it's sort of now into a what you see on the left, or you can kind of see the dashed lines over here from what the raster used to be, meaning our in grid. So what's happening is we're saying, all right, I'm going to go to the center. Here you can see the new 30-meter cell. I'm going to go to the center of that from the center that was one of those functions we talked about earlier in the spatial workshop of center cell method of, where does a output grid get the, or output raster get the value? And the predominant type is the, or center cell in this case, it's either predominant type or center cell being two of the more common, but this one happens to be center of the cell. So it's going to whatever that was right here, which would have been a value of 1. So that means, in this case, we're taking 1 times 4, and then the output the new output value in that cell is 4 in the new 30-meter cell size. So that's what's happening when we do the set cell. Well, I'll call it command, but now let's come back over here and let's drop in some, I'm going to remove this stuff here. I'm not interested in that. I'm going to go into my L89 folder. Again, this is the same folder that we worked off of last week. I'm going to go into my computer somewhere in here. I should just go back into my project if we can't get that open. So we'll go into, this is my work drive from last week. And I'm just going to go back into the week 1, even though we're in week 2, I'm going to go back into week 1 just because that's where I saved some of our grid training information, our grid intro. And I want to load in, just going to pull in our L89. I'll pull in all of these just in case we want to go over anything. We'll load those in. And again, we may need to zoom to layer on some of these. Again, some of these will be in different coordinate systems. Move this up. Okay. So zoom to layer. And we're not necessarily caring a whole lot about what our coordinate system is, but in reality, I'd make sure these are defined correctly as in the North American datum in 1983 for these anyway. But we've explored our data a lot here. And so what I wanted to show was just an example of how you think we could set up our cell, kind of using that set cell command, but not really doing the set cell command. But instead changing that. So for instance, in our environment, so recall that in our geoprocessing environment, we could change that here, or we could also change it, I think it was under, well, oh, okay, there we go. Insert, where was that? I think it was under the analysis tab there. You can also do that in your environments tab here too. But where do you think we could put that? Let's say we wanted to do a 30-meter cell size and make a copy. Any thoughts on what you might see in here? And all we're trying to do is to enforce a new cell size, similar to a resample almost, but just in a different way.
Did you put the 30 in the cell size?
Yep. Just highlight in our cell size block there, and then we'll type 30. And then we'll be.
In the parameters, you'd have to do the input grid that you want in the function box.
Yep. And then from here, it would just be, let's say we wanted to follow along. Let's have a little fun here and let's just say, we'll do the same thing. We'll say 4 times L89 calc 7-G. Let's try that. So right now I just have my L89 data up and running that we're all familiar with. I'm going to say L89 times with my operators here and say multiply by 4. So type in there 4. Now we'll have to obviously give this an output name. And I'll have to go back and save this here. I was a little bit sloppy in setting this up here, but let's make sure again, no spaces. We'll call this one, I'll just call it set cell demo. It's kind of an example of setting the cell size. I have this window up here. So let's go ahead and we'll save that. Our Zoom window is always in the way here. Can't find a good place to keep that. And let's run it. Okay, so noticeably, we see that our cell size increased, but now, obviously, we're working with our original data set there, but we have values of 1, 2, 3, 4, 5, 6, and 7. And now you can see all of our values in here. Let's open up our value attribute table and our L89 data. Here we can see our values. So all we were doing is taking number 4 times 1, 2, 3, 4, 5, all the way up through 7. And that was our output. So here, again, the colors are going to be different. Don't let the colors distract you, rather the values of what we're looking at. So here was 4 times 1, here's 4 times 2, 4 times 3, 4 times 4. So what would be a reason to do this? It depends on what you want to do. Everything that you're working with in terms of a expression over here should have a purpose. I'm just showing you examples of working with relatively simple things here. Questions from folks joining us live here or folks at home later on, send me an email. Let me know if I can help you out with that. Otherwise, that was an example. Now we shouldn't forget to take this out of here. Otherwise, any processing we'll do again will rear its ugly head for that. So in any event, we have a maximum of our input set, and recall that maximum of inputs would be the size that'll be the largest. Remember, the output, our output resolution will only be as good as our input data sets. Otherwise, the software is going to resample upwards because we can't make our data more accurate. If we have a bigger cell size, we can't make it more accurate by scrunching it up. We can change the cell size certainly, but our data is not going to be more accurate. So good. So we just worked through a little example there. It's akin to resampling, again, that we looked at, of setting the cell size. So other ways that you can enforce parameters. Let's jump to 436. I'm sorry, 446. 446. So we had a little bit of fun with this as it related to our activity assignment number 1 in working with masks. And so I think we have a pretty good feel-good understanding of a mask, but just as a brief review on that, with our processing mask, what we looked at is really you are it's kind of a way of thinking about a clip, but the advantage this has over a clip that you maybe noticed from our in-class activity, let me pull this up here. The advantage you may have noticed, why a mask might be a little bit better to use in some instances, is for this reason. We have to zoom to our layer. I'm just organizing them. I like all my active layers on the top. The reason, let me ask the people who are on live here tonight, what advantage does a raster processing type of mask offer that a clip would not? Potentially. The short answer to that is, whenever we have a raster that has a value, that raster will always have a value unless it's no data, but then it wouldn't be important to use probably anyway for us. But in this case, we have a value of 1 in our raster site mask here. Now, where that becomes important, now it's fine if you just wanted to clip that area out, but we're trying to process what's underneath there in that case. But the power is, like we ran last week with our condition statement, is we have the ability with the raster that has a value, we can start to enforce changes in our data. So changes in our value, changes in our output. That gives us a lot of leverage over just a traditional, raster clip. Sometimes a clip is fine, but I kind of call it like the simplistic version. Using a processing mask in a sense that we are here with our masking concept gives us a lot more, I'll call it analytical leverage, because of we're taking advantage of those values in our data. And so that's what's important to maybe remember for that. All right. Let's flip over to the next page here in 448 as we're moving through this. We had some opportunities to talk about this spatial language or map algebra, if you will. It's really, think of it as creating expressions to enable our data sets to be more powerful. It's a good way of thinking about that. But we've done some of these already. But this is a good example of a per cell based analysis. And again, you probably have read about that in your little power read through chapter 9, which is all about map algebra. Again, don't worry about the syntax so much as what the concepts are, generally speaking. But here just 0 plus 4 in a per cell analysis. 4, and we're just repeating that. So again, we're imagining that stacking concept going on. But we had to hit up a little bit of that in last week, so we should be feeling pretty good about that. Take a look at page 450 at some of the map algebra actions, the various operators that you'll be using, I think, quite a bit. Add, minus, greater than, equal to, that type of a thing. It's also different functions, working with sine, cosine of data, means or absolute values. And this nested statement that we see here is really where we could start to be pretty complex, where we can have, it's basically the order of operations. So for people that are really into your math and things like that, the ability to nest certain functions inside of bigger functions is really where the power of map algebra, and quite frankly, why I like to use different conditions, like these condition statements for these higher order types of functions. And because it gives us the power of data control, data quality, our outputs. There was an example a number of years ago where, let me just see if I can find that offhand, just since we're chatting here. Let's see. Oh, wait, this is the wrong one. So I'm going to search for a paper out here. Just to give you an example, there's a lot of really cool, we're talking about map algebra, different functions that are being used. I wanted to highlight a few of these because they are relevant, and these papers are great sources for you to go to look to see, wow, how was this actually being used in capstone work? Or what were people doing with that? Chad had a good example of when we're looking at back here with sine and cosine of different cells. In Chad's paper, I'm going back here a number of years, but he was doing a volumetric flow analysis on a cell-by-cell basis in the river. But he was having to, I don't remember all of it here just off the top of my head, but he was having to compute the cosine of value, the cosine of cells, because of the flow direction wasn't perfect, like a normal square cell, like the flow of the river or the water speed was in more of a cosine value of a cell, kind of like in a triangle type, like a trig function, if you will. And so his paper dealt a lot with understanding volumetric flow. And I'm going to see if I can just show you a little bit about his different flow equations and his raster that he had set up, but how he had to process the velocity, not like just a typical raster, but in a cosine, and so his was a pretty cool paper looking at different types of flow velocity rasters and what was actually happening in this river section at the time for what he had to compute. But anyway, he did a lot of work with that. Another paper that was really a wonderful paper was Martha Roldan, and Martha's paper was about, and this was an older paper before we had a lot of the super solid formatting going on here, so please know that. But Martha did a phenomenal project on working with map algebra, and essentially Martha was looking to understand how reforestation on agricultural landscapes have changed from, I think, here it was, like 1939 to 1993 in a watershed. But let's get down to some of the fun parts here. These are all available. You can go check them out. But I wanted to get down to the nitty gritty to show you how cool this was. But she had to create some data in here, different time periods. And when I said, like, the importance of, as an analyst, never lose track of the meaning of your numbers, because your cell values have meaning. They're just not numbers, they're meaning. So Martha's paper is a textbook, brilliant example of that. And so she was creating different data sets for what was wooded in the past and more wooded kind of in the 60s. And then she has one wooded of current. But she ended up in here, I'm going to try to get down here, talking about cell values of 2, and understanding how these layers or how these values were being aggregated together after multiple aggregations, if you will, to make sense out of those. And that's what I'm going to show you right here. So she derived this summary data from taking these 3 grids or rasters of different time periods. But, and I, again, offhand, I don't remember what was what here, but she had different values in here, and she was multiplying certain values together, but yet adding them together in what was called a sum grid. And we also kind of call this a ranking type of a fashion. We know whenever we add grid, it kind of implies a suitability type of model or a ranked model, because you're adding the values. The only time this wouldn't really work is if you had a lot of no data in here, but otherwise it's just going to add the information. So it's clean, it's simple. Whether it's 0 or it's not, it's going to add it together to this sum grid. So all these numbers to us, as we're looking at them right now, we're like, what does that mean? But in Martha's work, she defined that, what each one of those values meant and what they turned out to be. So here's an example of a little equation or something that she put together of these different rasters, multiplying them by 100 and then another one by 10, and pulling these things together. So moral of the story is, you can do some really, really neat things with this, so long as you can track what those values mean. So if you're into here's some more examples of these different nested statements, building these functions. It's just a marvelous job at this, pulling these things together. Just tremendous. I love it. Her project was so great, and had some really neat outputs from that as well to see where reforestation changed. So this, is kind of a cool example of a final project you could do for this class. Not obviously at this level or at this in depth, but you could find some areas of old vegetation and new, and do a little change detection on them. And we'll have an in-class activity that we'll post as well for this week in another video that shows some just bare bone principles that you can do this in not too much time. But I did want to show this because it was a pretty powerful paper, and Martha did a wonderful job on that. Okay. So a little sidebar there, but still helpful, hopefully. All right, let's jump to page 9.4. If you have people joining live, page 9.4 for folks at home. Take a look at 9.4 as we round out some of our general discussions on raster and spatial modeling, page 9.4. Okay. 9.4. I'm running 2 books, so a little bit trying to keep this all in order. So let's take a look at map algebra introduction. We've done some of this already, so shouldn't be a super big review. And if you'd had a chance to leaf through this, should be in good shape anyway. But typical syntax, we've seen this in raster calculator, that an equal sign for us, it's not displayed in ArcGIS Pro, but when we really in Pro are setting up an expression, kind of in between our, if we just clear, well, we can leave our expression here, but this expression, in this case, L89 times 4, just imagine that there's a little equal sign in here somewhere. There's an equal sign that gets routed to a new raster name. And that's really what this is saying to us right here. It's saying we're creating a new grid that's set equal to an expression, or two grids in this case, with an operator or an input that's adding the values between them. But the equal sign typically means that we're creating a, like we do in Pro, a permanent raster. So we're creating a permanent output from that. All right. And go with 912. Page 912. In our work. So page 912 here, folks. So this is a nice overview on operators and functions, as we're looking at this, on 912. And I'm, again, not super worried about the syntax because this is, well, here it's going to work okay. The syntax would be generally the same as in raster calculator, but not always. So we're kind of looking at, like, this function would be just fine if we took L89 calc 7-G plus L75 calc 7-G times another grid if we had one of that same spatial extent. Again, we're looking at same spatial overlay, where the order of operations would take place in multiplying first, and then adding the results of these two rasters plus the values of our input grid. So as we learned last week as well, parentheses we're using to control that order of operations. That's inside the parentheses gets processed first, and then it works outward from there. Here you see a couple of examples. Inside, even though, if you're typically trying to multiply these together, multiplication takes place first, unless we have parentheses around there. So I know that's a review probably for many people, but it's good just to recap a little bit here too. Okay, let's go to 914. Now, these are some examples here of output value types. And, in the geoprocessing tools, we can convert from integer to floating point or floating point to integer all you want. You can make those happen. And so being able to convert between is it's important. I typically don't convert a floating point to an integer too often, but it still can happen. And there are some different types of conversions. If we wanted to go from a floating point to an integer, we can use this int command, or when I say commands here, these would be tools available for us. I suspect if we looked in the geoprocessing toolbox, there'd be an int command or something to that effect of converting raster data to floating point raster data to integer raster data. And then also there is this would kind of be just an example of how we'd want to, what this would be saying here is name of a grid called round grid, like rounding a grid with the int command. So what we're doing here is taking a floating point, in this case, presumably the in grid is a floating point raster. They're adding 0.5 to the values on it. Why, I'm not sure, just to show you that it can be done. But they're adding 0.5 to the values of a floating point grid. And then they're going to essentially round that to the floor. So what that means, if it was 6.4, they're going to drop it to the lowest integer, so that'd be 6. So it's going to take it to the lowest decimal. It's not going to round it up. So, and then there's a ceiling command that could be used that in place of either take it to the next integer up. So, these are things that you can practice with or take a look at. I haven't really had a huge need to do that, but, we could look at this, we could try it. If folks are joining us live, do you want to try that? Are you okay with doing it on your own or trying it if that ever comes up? Should we try it?
Sure.
Okay. Heather, what should we do? So
I
we
know
have
you really
all-
want to.
What's that?
But I know you really want to.
Yeah, I kind of do. I love this stuff. This is great. So let's see, there's one of 3D analyst tools, image analyst tools, spatial analyst tools. We probably want the spatial analyst tool version, in which case, like the int command suggests, we're going to convert the cell value of a raster to an integer by truncation. So right now I have my CalTopo grid up and zoomed in on that. So you can do that if you want to follow along. Let's try that. So right now we have a floating point. One, I know that because there's no attribute table. And two, if I explore my data, you should also see that there is a floating point, or I might say unassigned character or something like that. But a big reason that we could tell this, or a big clue, is our attribute table. Let's try it. Okay. So our input will be CalTopo grid. Output, well, let's save this here to a new, well, yeah, here we go. We'll call this one int underbar demo. And we'll save that. And we should be able to run this. I suspect there are some other parameters that we could enforce, like we looked at. But now, if we turn off our, well, let's zoom in on this a little bit. And I'm going to turn off my, so you kind of see the difference between the integer and the floating point. I'm going to turn off my CalTopo grid. If I right click on my new int demo, we see that it has a value attribute table. So that means that what this did for us was it assigned values, to those cells, whether it rounded it up or down. I don't know what the default is on that. I'm not actually sure. I'd have to go in there and look to see if it rounded it up. If it was a decimal of like 410.6, did it round it up to 411? Something like that. I'm not sure. Or if it just dropped it all to the floor. I don't know what the default is. If somebody finds out, let me know on that. I'm not sure how Pro handles that. But nevertheless, we chunk those up into different counts now. So we have a VAT here, and that worked for us. Okay, it's fun to try. Likewise, we can try to break something up from we can move an integer to a floating point, but I don't really know where that is used too often, I guess, because usually we generate floating point rasters from point data, like sample stations or soil samples or temperature stations or whatever. That's how we generate, or bathymetry points. That's how a lot of this was created. So rarely do I see us going from it's kind of like trying to go from a really large size cell raster and making it more accurate. You can't really make it more accurate. So I don't know the reason why you'd want to do that, truthfully. Okay. Let's flip over and we'll keep on going here. On page 916, here's an example of some flexibility of what we can do. It's kind of like a join. I think of this similarly to a join. It's not really a join that we think of in our vector type of analysis world, but yet we can use, I have to move this window around here. Sorry about that. So what this is saying is we could create a new raster based off of user-defined attributes. So just like we looked at in our L89 Calc 7-G grid, that had user-defined attributes until we processed on it, then we lost that. But in this case, we could actually take user-defined attributes, which is what this means. So here we have our vegetation raster, and we have a vegetation hazard. Presumably these are ranked. I don't know if 1 is high and 3 is low, I'm guessing. And we wanted to add these user-defined attributes, or these ranked systems, based on the value of each cell here had a rank. So 1, 2, 3, but maybe that's not how they wanted to represent the actual rank of the type. So they added a user-defined hazard ranking, 1 being bad, 3 being, I don't know, not so bad. But so what we're doing here is taking the user-defined attributes for a vegetation raster, and we're adding it now to whatever this is, a soil raster and its foundation suitability. Again, I'm not sure what that is really. But they want to create a new raster by adding these values per cell in here of the original raster to come up with a new grid called suitability grid or suit grid. There we go. So you have to kind of look at this one, but what's happening is, let's say if we look at this number 2 up here, where did that come from? So this is a per cell type of analysis. So you're saying I'm going to the veg grid, which has a value of 2, which is here. Now I'm going to the fire hazard, which is a value of 1. So we're saying 1 plus, now whatever's underneath that. So here's a 1, a value of 2. So we're saying, oh, I'm sorry, a value of 1 with a foundation suitability of 1. Forgot what the other one was here now. So essentially 1 plus 1. So here we had a value of 2. 2 had a rank of 1. So 1 plus 1 equals 2. That's the output. So we can do a lot of complicated things with this. And I guess I'm always of the mindset to keep things simple. You know, if it were me, what I would probably do is just reclassify these, our veg grid, into a new grid. Reclassify these values into a new grid called, you know, fire hazard grid or something like, or fire hazard raster, whatever it is, that is reclassed to these rankings. And then I would do the same with the foundation suitability of soil. Then you could just add them, you know, without having to do all that. But the point of it is to know that you can do this. It's a little bit crazy, but you can. Let's go to 922. Everybody flip to 922. And we already talked about this. So this is just a quick stop and go right from here. On dealing with no data. You know, the default is, you know what, I've never really found that you can ignore it and compute it with remaining values. So if any of you stumble upon this and you know the setting to do that, please let me know. Otherwise, I just end up having to not process it, or I reclass it into something I can use. Otherwise, the default is no data in is no data out. Simple way to do that. 4 plus no data is no data. So last week, we got ahead of ourselves a little bit, but we had a chance to do this with no data when we were working with that. So a lot of this is kind of familiar to us now, but this was really what was happening behind the scenes for us when we had we took one of our, I think our L89 grid. Go back and folks watch that if you want to, but we basically took we practiced a lot with that. We did is null, where we ran a test for null values or no data. And we also took some values of our one of our rasters and we set it to null or no data. So this particular page on 924 outlines that a little bit. You know, we had some syntax up last week, and that's also, I'll be providing all, you know, sample syntax for you so that you have that. But this is a page that describes what we did. Okay, let's go to 928. 928. Let's take a look at our goodies here. How are we doing, folks? Live with us here tonight. Let's hopping through a few things here, and we'll do some summary items here. And okay, thank you, Nicole. Others doing a quick check. Okay, so 928. I encourage you to keep this handy. Whether, you know, I just encourage you to keep this page handy, because it's a lot of different operators, map algebra operators that you can use. Not only, well, you use them in raster calculator, but also in searching for tools, like, or functions inside of Spatial Analyst on Like we looked at INT, the int command. You know, these are just things I'm trying to expose you to. But the more common map algebra operators are listed here for you. These are good ones to always remember or to know, you know, as you're kind of scrolling through your options. It's nice to have these, here. But most of them that I've circled here, arithmetic or relational, are more often than not the ones that you'll probably use the most. So greater than, equal to, less than, equal to, arithmetic, etc. So as the name would imply, with our relational operators on 930 and 930, these just happen to be tests of logical comparison. You know, essentially, you have in-grid values. Are they greater than values of in-grid 2? So if we look over here, is 3 greater than 4? You know, 1 for true, 0 for false. Is 3 greater than 4? No. Therefore, the output is written to 0 in this cell. Again, a per cell analysis. So let's find another one. Is 3 greater than 1? Yes. Therefore, true. So a value of 1 for an output. So you probably noticed by now, but a lot of our default items in raster processing are 1s and 0s. Kind of a binary means of saying met the criteria or it didn't. You know, one or the other. Let's jump to 954. 9-54, everybody. Which for me is just the next page. So here we go. This one shows us a bit on what I had on my paper a few minutes ago, showing you the local, focal, zonal, global. As I mentioned, just about most of our work will be done on the focal or per cell, you know, what's in this cell and what's immediately underneath it type of thing. Focal probably won't use a whole lot of that, and zonal maybe in some statistics, like zones here and there, but global might be another one that use valuing all the cells together on a layer. But I'm focusing a lot of our work here on the per cell level. Let's take a look at an example of a local, or what we'll call per cell analysis or sample here. Okay, so here's an example of just using an abs or a square root, I guess in this case, a square root function. I'm just saying, okay, I'm looking at this cell and, well, in this case, they're just looking at the square root of one cell. Saying, okay, well, that's 2. And the output, you know, would be written, you know, in the same spatial extent. So pretty simple, pretty straightforward. Let's go to 960. Just hitting some of the highlights. This week, you're going to be working with a lot of, move this over. Or I suspect a lot of different reclassification functions. And this is a local function called reclass, as you might be able to see there, whereby what we're going to do for that is, you know, purely just take an in-grid or whatever our grid is that we want to change. And in Pro, this is pretty easy. We just open up a table in here. We type in for geoprocessing reclassification, reclass by table, reclass. I mean, there's a lot of them in here that we can look at, but reclass spatial analyst tools reclassifies or changes the values of a raster. And we could try that. Let's take a look though at what this is doing first. So really what we're doing is we're saying, okay, computer, I want to change these values to something else. Here's a great way that we could modify no data. In that, down below here, you kind of see this table where we could say, you know, this is kind of what we're telling pros, or saying, all right, They have a range of values of, in this case, anything that's in the range of 1 to 2, I want you to call it a value of 1 in the output table. So anything that's a 1 or a 2 here will be called all now a value of 1. Anything that was between 3 and 5, so you see, 3, 4, and whatnot, those are written to values of 2. That's pretty much what we're doing. Here's something I want to highlight for you, though. I really want to highlight this. Some people really want to reclass their way out of everything. They think that they can reclass their way out of everything. But keep in mind, reclass is not an analysis. Reclass only changes or derives your data. It can only derive data, but it's just changing values. It's not analyzing anything. So keep that in mind. You can only reclass your way out of so many things before you get stuck. Reclass only changes your data, your values. So it's not analysis. So we can kind of think of it where I have a grid query or data derivation. You'll learn about this with the Brian problem this week a little bit more in some of our activities here, some other videos. But reclassing is only subsetting or deriving data out to something else that we can use, but it's not the integration part. It's not condition statements where we can flex and generate new data. So keep that in mind. You can only reclass your way so far. You can't reclass your way out of everything in most instances. Let's go ahead and try to reclass, shall we, folks joining us here tonight? I'm going to remove my int demo. Do not need that. I'm just going to minimize my site mask. I'm going to bring up my old CalTopo grid here to the top. Just for fun, let's do a reclassification of our data here. Yeah, we'll have to zoom to layer. Now, let's go ahead and reclassify or change the values in our L89 data. Oh, here we go. Here's a tool down here. So the reclass tool, a toolbox, here where we can do that. Reclassify. So let's open that up. Input raster. I'm going to say L89 calc 7-G. Now here's a choice for you to make. I guess you could do that off of value. I suppose you could do it off the description here too. If you know the description and what that description means for the values, you can do that. Otherwise, you'll have to know what the numbers mean in order to make that reclass. You know what? I don't know if I've ever tried it off of a description. We could try that. Typically, it's going to be values, but open water, we'll call that, so we have value, open water. These are all, this is 1, 2, 3, 4, 5, 6, 7, and of course, no data. But so just happens to be that we know the description of our values, which are 1, 2, 3, 4, 5, 6, 7. So for new, let's call this one, let's say we want to put anything that could be potentially water-based, we want to call 1. So marsh, that's kind of a 1, 2, it's kind of watery. Now, let's say we want to call anything that might be kind of grasses or trees, we're going to call 2. And then agriculture. Agriculture we'll call that 3. And then anything urban and developed we'll call 4. Anything that's sand and mud, let's see if we can put no data in there. I don't know if that'll work, but we'll try it. How about testing here? So there we go. Anything that's potentially water marsh should be written out as 1s. Anything that's vegetation oriented, 2s. Agriculture 3, and urban and developed 4. Now let's save this to our directory here. I'm going to call this one reclass demo. I'll save that. And let's run it, see what happens. Okay, so it looked like this ran okay for us. Again, pause the recording, folks. If you're at home watching this, you can check out all the goodies there if you need to. But it looks like this did some good work for us in here. Now, the areas that were kind of that sand and mud, I'm not sure where those are in here. I'm sure they're in here, but they wouldn't have a color on it. Anybody at home tried? Let me know if you found those.
Well, it'd be hard to see because you have the layer underneath on too.
Oh, I'm sorry. Yeah, I'm sorry. I'm sorry. My bad. My bad. Rookie mistake. All right, here. Maybe in here, is this no data? No data, there we go. So that's kind of the mud and sand. So it did work, good. Of course, we have no data up here that we left as no data. Yeah, that looked like that worked for us, but always explore our data, check our attribute table. And there we go. So 1s, 2s, 3s, 4s. So that's an example right there of what we did with the reclassification. You know, we can only reclass, change the values, but we're not really analyzing anything. We're just subsetting or deriving data in a way for it. All right. So I'm looking at 962 here, and you know, these I'm not super worried about these. These are kind of like the focal, sometimes used like in general modeling for imagery and things like that. I'm not super worried about that stuff for you all. I mean, you can leaf through those pages in your manual, but I'm not, again, super worried about that. Now, let's jump to 982. I want to hit on some of the more important components that you might encounter. And one of them, so we looked at the Purcell a lot, and we kind of jumped over the zonal and focal, but global is another one that we'll want to look at because it's one we'll use a little bit more. And again, here's a funny mishap. Remember we talked about the orthogonal connections? This one not going to fly like this. It's not good. You know, this cell should be all blocked in. So we use the global functions for cell by cell integration, if you will. And this whole process is recording the identities of cells. It's recording the values. It's looking at cost distance relationships in here as you're looking at your graphic. It's running auto accumulation of cells as it's processing through. Again, I think of this as like a source and sink type of a thing, like if it's a source and then there's a sink, or maybe used in utilities where there's a source of origin and a source of depletion, not like a network analysis necessarily, I mean, kind of, but more of a raster basis in that regard. So, but anyway, global, they're cool, but we're focused on the main areas there of our Purcell and our global a bit. But let's take a look, flipping over to chapter 10. And in chapter 10, in that manual, the one I'm really most interested in stepping you through, and we did that already, so it's not that big of a deal at this point, but you know, you can look through, you know, I don't know if you really want to do the test. We kind of did that like a test for no data where we did an is null. It's kind of a test. That test function does the same thing, and I don't even know that we need to really do that, but you could write if statements, but I think they're, you know, like for coding, they're kind of like the same thing as a con statement, but con I like because we're performing multiple statements. And I just want to briefly look at pages 10, 12, and 10, 14, and that's where we'll leave it, you know, for our manual here. But let's go ahead and take a look at page 1012, if you want to flip over to that. Or I'm sorry, 1014. I'm sorry, 1014. Okay, so the con statement, as you may know from now and looking at this, we're referring to a conditional statement. In other words, what that's saying is conditions need to be met before something can happen. And if they do happen, you control the parameters or the values by which that are communicated out into a new raster. That's why I love this. You all have the power. So that is a good way to think about this, is that you have the power to control this. And that's cool. So the usage on this would be the condition, of a raster or whatever, condition meets whatever L89 is tested and evaluated for, using, that kind of double equals that we see there. It's a test for equality. Wherever that was true, then we can write a value. The defaults are typically 1s and 0s on that. But here's an example. And we're familiar with on the condition where in-grid is greater than 6, where cells are greater than 6. Let's write a 10, which is true. This is our true. And this, where it's not true, write a false. So when we looked at Martha Roldan's project of Coon Creek and how she was doing that reforestation type of example, she was doing a lot of this and changing the output parameters to different numbers like 100 or 10 if it wasn't true, because she had a system in her design that I don't remember anymore about she needed to control the output values. That's where this type of a setup gave her control, the power to change the values into something meaningful. While part of one of our rules, recall again, is knowing exactly what our values mean and what we want to create out of them. That's why I love this one and why it can be really helpful for you. So there's some other examples on 1016, kind of written in different ways. It's just mainly for ideas. So if you want to scope those out, that's great. And otherwise in chapter 10, I mainly wanted to focus on the con statement to get you acclimated with that. So with that in mind, I'm going just to stop my share and ask if anyone has any questions or anything like that out there. Anything that you'd want me to highlight. Otherwise, there's. Oh, Devin?
I was just gonna say no question.
Okay. And the point of it is in all of this stuff here is that, these are resources to make you aware. It's not anything that you have to memorize or anything like that. These are guides. They're there for you. That's the important side of things. But so with that being said, for our demo and our workshop, there's always more things we can tinker in and whatnot. But if anybody has any questions on it, let me know. I'll be happy to set up a session with you and go through some sample statements. And to that end, I should actually point out here that there are some sample syntax statements. I can get rid of that Zoom window out here. Word solution guide. At least in this term here, you'll see a word solution guide right here. This provides just a number of different sample syntax. Some things that we worked on in class, working with a mask, controlling our parameters with con statements. There's also some demo syntax that we'll be working through in another video that'll be posted this week. Just run through different scenarios of how you can solve these problems with different syntax. So this is really like I said, a solution guide for this week. The Brian problem that's out there for this week ran through the same things in an applications for how to apply this. Again, they're all just samples. So you can read through these, input them. It's a little guide for you. So otherwise, that should wrap us up for our week 1 workshop, but we'll also carry forth here with some additional videos and in-class activities that we'll make available for you all as well. So I'll stop sharing and stop recording and then end this session here for us for the spatial workshop.